In this first example, we're asked to consider the minimization of the perimeter of a dump site for a local garbage. The dump site's going to have an area of 2,500 meters squared, and we're going to determine the dimensions which will allow for the smallest possible perimeter. The problem's made a little more difficult because to add to this, there's going to be a river that runs along the west side of the dump that needs no fencing. Remember that the minimum perimeter happens in this case when the length is twice the length of the width, because we're only dealing with 3 sides for the perimeter. So here's an illustration of our problem. We've got the dump site with the river running on the west side of it. So we've got 3 dimensions here that have to be considered when dealing with the perimeter. So we're given that the area is 2,500 meters squared, and we're required to find out the width and the length for this dump site. The formula we're going to use is that the area of a rectangular object is length times width, and we're going to substitute in some values that we know. We definitely know that the area is fixed at 2,500 meters squared, and we also know that since we're fencing in 3 of the sides, that the length has to be twice the value of the width. So we've substituted in here, rather than having L, we've got 2 of the widths, 2W. We're going to solve this and rearrange a little bit. And on the left-hand side, we have 2W times W is 2W squared, and we have our 2,500 on the right-hand side. Now our goal is to get W all by itself, or isolated. To do that, we need to get rid of this value of 2 in front. Now that 2 is multiplying by the W squared, so we need to do the opposite operation, which is division. So we're going to divide both sides by 2, and we get W squared equals 1,250. Now to get rid of that squaring, we need to take the square root of both sides. And if you take the square root of W squared, you're going to get W, and the square root of 1,250 is 35.4 meters. So our width is 35.4 meters, and to find out our length, we sub that back in, knowing that the length is twice the width. We can multiply by 2, so 2 times 35.4 gives us 70.8 meters for the length. Therefore, the optimal dimensions for this dump site happens when we have a width of 35.4 meters and a length of 70.8 meters.